Okay, so from today we are going to start Ospf. In the IGP protocol, we learn regarding RIP, AIGRP. Okay, so now we'll go to the Ospf. CCNA level में हमले जुन basic तपाईको चाहिँ Ospf हामीले configure गरेको छ. So first of all, we'll just check the overview of Ospf, and then we'll move for the configurations and all. Okay. So first thing, Ospf means open shortest path first. Okay, and it runs over the 89 port number, and you run गर्छ, and it also go for the multicasting है जुन तपाईको नेबरशिप बन्ने एउटा प्रोसेस छ जुन हामीले लास्ट टाइम डिस्कस गरेको छौं इन द तपाईको AIGRP also. So the same as it also use the multicast, that is 224.0.0.5, and there is one more address that is used for the multicast, that is 224.0.0.6. okay. Basically in the OSPF there is like one of the DR and BDR concept that you have learned in the CCNA level. So like that, for that updates and all, it's gonna use 224.0.0.6, and for the neighborship process to send the hello message and all, it's gonna use 224.0.0.5. So these two are the multicast address that is used on the OSPF. And OSPF also has a process ID. Okay, and here the process ID doesn't matter whether to form the peer, to form the neighbor between two routers, and to exchange the updates and all. The process ID can be same or the process ID can be different. It doesn't matter, but you can mention the process ID from 1 to 65,535. So process ID, it can be different. Okay, but it's just like a AS number, autonomous system number, you can call it as like that, but it's a simple process ID, so it can be any number between 1 to 65,535. So whenever the two routers are going to form the peer, then they can have any of the process ID. Whereas in the AIGRP, we used to have the same AS number must be mentioned to form a neighbor, but here that is not mandatory. Okay, so that is a thing. And here one more thing is introduced, that is area ID. Okay, and here the area ID is of 4 byte nowadays. Okay, 4 byte means from it start with the 0 and it's something like a 4 billion. Okay, so before when it was of 2 byte, it was of only this much, 0 to 65,535, but now it's become to the 4 byte. So it means 32 bit. Okay, which is something like a 4 billion of IDs you can mention. But here in the among this area, the backbone area, the main area is area 0. Okay, the main backbone area is area 0. So let me go over here. So whenever you are planning to configure the OSPF scenario and all, then in that period of time, okay, so for example, I have a connections over here, and OSPF is a very large, OSPF can support a larger prefix, okay, larger number of routers than that of even than that of EIGRP. So it can be used for the larger network scenario also. Fine. So like this of connection is there. So let me connect it. So here, okay. So basically what you do is that, for example, to form the neighbor between the R1 and R2, you can mention any of the process ID. The R1 can run on the process ID 1, and the R2 can run on the process ID 2. Okay, so in the area, in case of the area, but in area, the particular link, the particular neighbors, if R1 and R2 wants to form the peer, then this would be on the same area. That is the case. Okay, in the process ID, it doesn't matter whatever the process ID may be, but in the area ID, first thing is that the area ID must be same between a peer. Okay, so for example, if this segment wants to form the peer, if R1, R2, R3, there is R4 and R5 is there. Okay, for example, then if R2 and R3 wants to form the pair, or R1 and R2 wants to form the pair, then this particular link, or this R1 and R2, the connected link between them must be on the same area. It can be on any area, it doesn't matter. Either it can be on area 10, it can be on area 0, but this should be on the same area. It cannot be like this. For example, you advertise this half of the link on the area something from the R2 side, you advertise on the area 5, and this side you advertise on the area 10. Then they will not form the pair. Okay, they must be, the particular connected link between the pair should be of should be on the same area. So this should be on the same area. Okay, and also obviously the prefix between them should be reachable. That means it should be of same prefix. Okay, so here I can assign the different area, like between the R2, R3, R4 and R5 up to here. I can assign area 0 if I want. Okay, so over here from R1 and R2, and moreover to that I can assign, for example, area 5, and from R2 to R5, R6, like this. And furthermore connections, I can assign the different area, like I can assign like area 6 or any of the area that I want. So over here I can assign area 10. So like this I can assign for area like because 2, area 3, like this I can assign. But why we try to create the multiple area is that basically what happens is that Ospf is a link state protocol. Clear? The first thing is that the Ospf is a link state protocol, like this. So whenever you connect, whenever you try to deploy the OSPF in your network, so once it become larger and larger, and then what happens is that in that case, for example, these all 3 routers belongs to the same area, maybe on the area 10 or something like that. So this is a router 1, and this is a router, B and C. So there will be some prefix over there also on area 1, for example, 11.1.0.0 slash of 26-bit. It doesn't matter whatever the subnet may be, 11.1.2.0 slash 24. So like this can be here. Okay, so what happens, whatever the routers associated routers and their connected link are advertised in the OSPF. Okay, it should be advertised on OSPF first. So after that, the R1 will send, R1 should contain the complete information of each and every links that is associated to this single area of that area. Okay, right now A, B, C belongs to the area 10. So the A should contain all the informations, okay, all the links associated to it, as well as all the links associated to B, C, or any of the other router that is going to associated to this area. Complete information area 1 okay. It should contain all the link information, all the connected link information over that area, and all the router information, we can say router information associating to the OSPF of this area. Okay, so what happens is that once our network increases, for example, we have 200 of routers, 300 of routers, and they have maybe like 50,000 of rows or prefixes, or the 60,000 of prefixes, like that. So it will be too much difficult to troubleshoot, first thing. So in that case, we can divide our we can go to the multiple area. Clear? So for example, before the A router should contain the information of how many others topics you concern. Oh, because in the area 10 maybe in before say सबैमा include गर्थ्यो भने 1 2 3 4 5 6 almost तपाईको चाहिँ 6 routers को complete information राख्नुपर्छ along with their associated links. Okay, मैले अहिले चाहिँ 6 मात्र लेखेँ. I just write the 6 only over here, but whatever the तपाईको associate हुन्छ त्यो complete राख्नुपर्ने हुन्छ के. Maybe on the area 10, if there is a 200 routers, then it need to contain all the informations of 200 router. And not only to the A, the B also has to contain all the informations of 200 routers over here on the area 10. Also the C also has to contain all the informations of the area 10. Okay? Complete information, and this should have the same what you call routing informations. This should have the same router information or the link informations associated to them. Okay? सेम तपाईको इन्फर्मेसन हुनुपर्ने हुन्छ. सो त्यो कारणले चाहिँ वन्स तपाईको चाहिँ नेटवर्क लार्जर हुँदै जान्छ, सो त्यो टाइममा इट विल बी डिफिकल्ट टु ट्रबल सुट. Okay, and also तपाईको चाहिँ के हुने भयो भने because of this region, because it contain all the informations within a particular within all the routers associated to that area. So त्यो भएको कारणले पनि जति पनि हामीले राउटरलाई चाहिँ इम्प्लिमेन्ट गर्छ त्यो राउटरहरू चाहिँ के हुनु पर्यो लाइक सुड बी अफ सेम क्यापेसिटी के सेम क्यापेसिटीको हुनु पर्यो. दे सुड ह्यान्डल अल द लिङ्क्स इन्फर्मेसन, दे सुड ह्यान्डल अल द प्रोसेस लाइक द्याट. Okay, so rather than that, we can go and divide it. For example, I can divide it to the area 20. Then now, for example, before it was containing all the 6 informations, 6 router information, but now it can contain only कति तपाईको चाहिँ now उले चाहिँ तपाईको only कति भयो 1 2 3 4 4 राउटर्सको इन्फर्मेसन मात्र राखेको कि. सो यो एरियामा एरिया 10 मा बिलोङ गर्ने राउटरहरूले, whereas एरिया 20 मा बिलोङ गर्ने राउटरहरूले कति इन्फर्मेसन राख्यो, राउटर इन्फर्मेसन्स अर द लिङ्क एसोसिएटेड इन्फर्मेसन चाहिँ उसले 3 वटा मात्र राख्नु पर्यो कि. सो दिस इज हाउ यु क्यान डिभाइड योर सिंगल एरिया टु द मल्टिपल एरिया एन्ड इट विल हेल्प यु फर द तपाईँको चाहिँ प्रोपर म्यानेजमेन्ट अफ द प्रिफिक्स होइन, प्रोपर म्यानेजमेन्ट अफ द जुन ट्रबल सुटिङ गर्नको लागि पनि तपाईँको चाहिँ के गर्छ, हेल्प गर्छ ल. सो यसरी तपाईँको चाहिँ हामीले ओएसपीएफलाई युज गर्न सक्छौँ. सो त्यही भएर चाहिँ हामीले मल्टिपल एरियाहरू चाहिँ क्रिएट गर्ने गर्छौँ ल. क्लियर? सो द्याट इज अ केस. सो अब होइन तपाईँको चाहिँ स्मल नेटवर्क छ भने यु क्यान मेन्सन विथ द सिङ्गल एरिया, यु क्यान प्रोसिड विथ द सिङ्गल एरिया. ओके, किनभने तपाईँको चाहिँ लार्जर नेटवर्कमा चाहिँ के भइदिन्छ भने अघि मैले भनिहालेँ. सो वान्स इट अब हाम्रो नेटवर्कहरू हामीले एक्सपान्ड गर्दै जाँदाखेरि हामीले तपाईँको एड गर्दै जान्छ अरू राउटरहरू, राउटर सँगसँगै अरू लिङ्क्सहरू एड हुँदै जान्छ, इन्फर्मेसन्सहरू एड हुँदै जान्छ. लिङ्कको इन्फर्मेसन्सहरू तपाईँको चाहिँ लार्जर हुँदै गइसकेपछि चाहिँ प्रत्येक राउटरहरूले एउटा आइडेन्टिकल इन्फर्मेसन राख्नु, सेम इन्फर्मेसन राख्नुपर्ने भएको कारणले चाहिँ एउटा सेम डाटाबेस राख्नुपर्ने हुन्छ कि. जुन एले डाटाबेस राखेको हुन्छ रिगार्डिङ द्याट एरिया, बीले पनि तपाईँको त्यही डाटाबेस राख्नुपर्छ, लिङ्क डाटाबेस भन्छ. सो द्याट्स वाइ ओएसपीएफ इज नोन एज अ लिङ्क स्टेट प्रोटोकल भनेर पनि भन्छ. लिङ्क स्टेट इज अ राउटिङ प्रोटोकल. Clear? So if that is your larger network, then proceed with a different multiple area. If that is your smaller network, then you can simply proceed with a single area also. No issue, right? Clear? So that is the reason. So in order to break the identical, what you call it, link state database to be larger and larger, so we just proceed through the what you call it, multiple तपाईको चाहिँ एरियामा हामी proceed गर्छौं. ठीक छ? But here one more thing. So once you are planning to deploy the multiple area, okay, त्यो तपाईले मल्टिपल एरिया डिप्लोय गर्ने प्लानिङ गर्दै जाँदाखेरि चाहिँ के भइदिन्छ भने तपाईको यसमा जस्तै अब यसमा तपाईको के गर्ने भन्दाखेरि जस्तै तपाईको मानौ R2 contains area 5, area 0 and तपाईको area 6. So what will happen is that whatever the routers are there on the area 6, so these all the routers are going to make a communication to each other. They are going to exchange their link state database. Fine. Within a same area, they are going to exchange all the information, all the link state information, and they are going to build up the database table, link state database table. Similarly, on the area 5 also, whatever the router will be there, they are going to build up their identical link state database table, and they are going to make the communication to each other. Similarly, same thing will happen in the area 0, area 3, area 2, and area 10. But whenever we talk about exchanging the information from the area 6 to area 0, or whenever we talk about the how the information is going to be shared between the area 6 to area 0 or area 6 to area 5 like that, then what will happen is that basically the different area, except then that of backbone area, that is area 0, they are not going to exchange the information. Like for example, if there is no any area 0 connected with the R2, then the R2 holds the information of area 5 and area 6, but it's not going to exchange the information between them. Clear? Your information exchange huँदैन. So that's why we need to connect it with the area 0, so that the area 6 will pass the information to area 0 and then area 0 to area 5. Clear? So to be like to exchange the information between the different area, the particular normal area should connect to the area 0, to connect to the backbone area मा चाहिँ तपाईको connected हुनुपर्ने हुन्छ ल. Otherwise, it will not exchange the information between the different area. Like for example, if that is a different area, like you connected some of the routers over there, like this. Okay. So भने यसमा चाहिँ के हुन्छ तपाईको जस्तै पार्टिकुलर एरिया बीच कम्युनिकेसन हुने भयो जस्तै अब अहिलेको कुरा गर्दाखेरि यो एउटा एरिया रहेछ पार्टिकुलर ओके यो तपाईको एउटा पार्टिकुलर एरिया छ भने यो तपाईको फर एक्जाम्पल दिस इज योर एरिया 10 and this is your area 5 or it can be anything, then 1 2 3 4 router will build up one of identical भनेको सेम ल identical तपाईको के गर्छ लिंक स्टेट complete database क्रिएट गर्छ ल र यसमा के हुन्छ 1 2 3 4 बीच कम्युनिकेसन पनि हुन्छ and the same thing will happen to the area 5 with the area 3 sorry 3 4 not 4 3 I can say 5 I can say 5 3 5 and 6 router. Okay, that means this one, the router that contains area 10 on one of the side and area 5 on another of the side is called ABR router. Area border router. Okay, so this router will hold the database of area 10 as well as the area 5, but it is not going to exchange the यो तपाईको database चाहिँ एक आपसमा exchange हुँदैन. So that's why what we need to do, we need to proceed with the area 0. At least there should be area 0 that is connected to the R3 router. So there should be के हुनु पर्यो area 0 चाहिँ हुनु पर्छ present हुनु पर्छ ल. At least on the look back, no issue. यदि तपाई area 0 deploy नगर्ने भने at least on the look back area 0, because area 0 is like a main area भनेर बुझ्दा पनि भयो ल. ठीक छ. So यो तपाईको कन्टेन्ट गर्नु पर्ने हुन्छ. So that is what you need to understand. So moreover, you can deploy whatever the area that you want, but it should be connected to the area 0. So it's like a central area or it's like a main area in the Ospf. Okay. So one more thing, again, I want to say that if that is your very large network or large deployment over, try to create the multiple sub areas so that it will be easy for you to break the single database or to break the identical what you call link state database, or to break the single database containing the larger network, containing the larger informations. Okay, so it will be easy to manipulate also. Okay, so if something happens in the database table of area 10, then we can area 10 में के issue आयो भने हामीले area 10 को database हेर्न सक्छौं हैन. area 5 में के issue आयो भने हामीले area 5 को database हेर्न सक्छ के. So it will be easy for us. Clear? So that's all you can do it. So here, so the same thing. So Ospf like के भन्छ तपाईको? Ospf is one of the link state protocol. Okay. Link state protocol भन्छ ल. Link state protocol किन भन्छ भन्दाखेरि किनभने तपाईको चाहिँ Ospf मा कुनै पनि एरिया सँग एसोसिएट भएका कुनै पनि राउटरले, that can be router 1, router 2, router 3, router any of the router that associate with the or that is advertised on the or that is linked to the Ospf. Okay, or that uses that has in Ospf enabled over there. Then in that period of time, it will generate one of the link state database will generate again. Link state ke huncha? Database generate garcha. Ospf has a capacity to define or to detect the link, whatever link it is. Either that is a point-to-point link for the serial connections. There are serial connections हो भने चाहिँ के हुन्छ तपाईको? The point-to-point link हो, या तपाईको चाहिँ P2P link हो, या that is a broadcast link. If that is Ethernet connections, then that is a broadcast link, or that is a point to multi-point link, or that is connected to the multiple connection from a point, or that is a point to what do you call a broadcast means shared link. So it is going to define that. So basically तपाईको चाहिँ link चाहिँ detect हुन्छ on the basis of what तपाईको, on the basis of encapsulation protocol associated on the link. Link मा प्रत्येक link मा एउटा encapsulation protocol हुन्छ. Like if that is a Ethernet, then it is noted as a broadcast. Okay, If that is a what you call SDLC, encapsulation protocol is SDLC or PPP, then that is a what you called, यो चाहिँ तपाईको एउटा के हो, point to point link हो ल, स्पेशली अन्त यो चाहिँ सिरियल लिङ्कमा हुने गर्छ, यो चाहिँ इथरनेट लिङ्क्सहरुमा हुने गर्छ ल, point to point भयो. So point to point means no more than 2 connection can be held. Okay, and broadcast or Ethernet means there can be multiple connection that can be held from a single point. So that is a point. यो चाहिँ के भयो तपाईको, यो चाहिँ एउटा shared भनेर भन्दा पनि हुन्छ broadcast, and this is your what you call point to point link ल, यो चाहिँ point to point connection भयो. So in the broadcast, one particular router can have a neighbor from in the same network to the multiple others. In the point to point magic single hune garcha la, single only 2 routers can be connected on a link. दुईटै मात्रै तपाईको कनेक्ट गर्छ ल. सो जुन लिंक स्टेट डाटाबेस छ यो एउटा तपाईको डिटेक्सन भइसकेपछि यो इन्फर्मेशन्सहरु फ्लो गर्ने गरिन्छ हैन. सो एउटा तपाईको चाहिँ प्रत्येक राउटरहरुले इन्डिभिजुअल जुन जति पनि हामीले ओएसपीएफ मा एडभर्टाइज गर्छौं, सो इच अफ द राउटर जेनेरेट लिंक स्टेट डाटाबेस. नर्मली कहाँबाट त भन्दाखेरि तपाईको चाहिँ लिंक स्टेट एडभर्टाइजमेन्ट हुने गर्छ ल, लिंक स्टेट एडभर्टाइजमेन्ट भन्छ, पछि हामी पढ्छौं त्यसलाई भन्छ एलएसए भनेर भन्छ ल. ओके, they generate one of the link state database by the use of link state advertisement process. Clear? What happens is that यसमा चाहिँ तपाईको चाहिँ कसरी जेनेरेट हुन्छ पार्टिकुलर एलएसए भन्दाखेरि चाहिँ थ्रु दी नेबर प्रोसेस. अब यसमा चाहिँ के कन्टेन्टहरु हुन्छ भने एउटा एलएसए मा चाहिँ तपाईको चाहिँ इन्फर्मेशन्सहरु कन्टेन गर्छ रिगार्डिङ व्हाट तपाईको नेबर्स of that link. Okay, the particular router is connected to a neighbor. Okay, so the neighbor of this link एउटा त्यो इन्फर्मेशन्सहरु भयो. अनि टु रिच फ्रम अ पार्टिकुलर एउटा पोइन्ट देखि अर्को पोइन्टमा रिच गर्नको लागि तपाईको कस्टहरु कति चाहिन्छ, पाथ कस्टहरुको कुराहरु आउँछ ल. कस्ट भनेको चाहिँ मेट्रिक इन द व्हाट यू कॉल इन ओएसपीएफ. Okay, so for any of the topic point or any of the destinations, it's going to calculate the path cost. So that is defined. Particular path cost or define. So this information source LSM normally running also. Okay, so isko आधार मा यो नेबर्स अनि पाथ कस्ट यो बीचको तपाईको चाहिँ कति छ, तपाईको यसमा कस्ट कति एसोसिएट छ भन्ने कुराहरु हुन्छ र त्यो कस्टको तपाईको चाहिँ आधारमा चाहिँ उनीले यो इन्फर्मेसनको आधारमा चाहिँ एउटा डाटाबेस टेबल क्रिएट गर्छ जसलाई हामी एलएसटीपी टेबल पनि भन्छ ल, लिंक स्टेट डाटाबेस टेबल क्रिएट गर्छ र यो इन्फर्मेसन चाहिँ तपाईको फ्लो हुन्छ बिट्विन इच अफ द राउटर्स. एन्ड एउटा एरियामा बिलोङ गर्ने राउटर जति पनि छ त्यो सबैसँग के हुनुपर्छ, आइडेन्टिकल लिंक स्टेट डाटाबेस कन्टेन्ट हुनुपर्ने हुन्छ, सबैसँग कम्प्लिट तपाईको के हुनुपर्ने हुन्छ, सेम इन्फर्मेसन चाहिँ हुनुपर्ने हुन्छ ल यसमा. अब बेसमा सिलेक्सन कसरी गरिन्छ त, जस्तै इफ यु हेभ अ मल्टिपल तपाईको चाहिँ लिंक्सहरु छ भने त्यो कन्डिसनमा अब बेस पाथ इज सिलेक्टेड. जस्तै फर एक्जाम्पल I just want to say it only, okay, I can say it only 3 or 4 links over here like this. So I have a connection. For example, I have one of the network over here. Okay, so what will happen is that each of the link will have a cost. प्रत्येक लिंक को के हुन्छ तपाईको एउटा कस्ट हुने गर्छ ल. फर्स्ट थिङ त सबै लिंक एउटा तपाईको एउटा पार्टिकुलर ब्यान्डविड्थ हुने गर्छ. मेबी इट हैज अ 10 MB per second, maybe it has a 100 MB per second, maybe it has only 10 MB per second, maybe it has a 100 MB per second, and it has a 100 MB per second, and maybe it has a 1000 MB per second. So each of the link will have a particular bandwidth. Okay, so the cost has been calculated by the reference bandwidth over what, over the तपाईको reference bandwidth को ओभरमा तपाईको link bandwidth ल. अब same parameter राख्ने भने it will be on the mbps मा हुन सक्छ, or else you can go to the bit per second, it doesn't matter. In default in Cisco the reference bandwidth will be 100 MB per second. Clear? So if you calculate the cost of what you call 10 MB per second in this case, भने cost कति निस्किने भयो तपाईको, reference bandwidth divided by bandwidth same unit मा हुनुपर्छ. If you are going to calculate on the mbps, then the link bandwidth should be on mbps. If the above was of kbps, then convert it to the kbps है. otherwise different होला, divided by 100. So equals to you get the cost is 10. तपाईले कति get गर्नु 10 गर्नुभयो ल. For 100 Mbps 100 divided by 100 equals to 1 भइहाल्यो ल. For 1000 Mbps 100 divided by 1000 that means 0.1, but हामीले point मा लेख्दैन, so negotiated as a 1 हुन्छ ल. So भनेपछि over here the particular link cost as a 10, it's of 1, it's of 1, it's of 10, यो 1 हो, यसको 1 भयो भनेपछि to reach from R1 to this destination, यो destination मा reach गर्नको लागि from R1 को केसको कुरा गर्दाखेरि चाहिँ R1 R2 R3 भएर पनि reach हुन सक्छ, R1 बाट डाइरेक्ट R3 भएर पनि reach हुन सक्छ, R1 R4 R3 भएर पनि reach हुन सक्छ के. बट among that कुन चाहिँ बेस्ट हुन्छ त भन्दाखेरि अब यो मध्ये तपाईको चाहिँ इट्स गोना युज द SPF एल्गोरिदम भन्छ, शॉर्टेस्ट पाथ फर्स्ट एल्गोरिदम भन्छ. ओके, सो शॉर्टेस्ट पाथ फर्स्ट एल्गोरिदममा चाहिँ यसरी कस्ट क्याल्कुलेट हुन्छ तपाईको र लोएस्ट कस्ट इज इलेक्टेड के. सो भनेपछि फ्रम R1 R2 to R3 यू गोना गेट 10 plus 1 plus 1 equals to 12, and from R1 to R3 directly that is just a 10, and from R1 R4 to R3 that is 1, R1 to R4 1, path cost is 1, R4 to R3 the path cost is 1, and from the destination the 12 मा reach गर्नको लागि R3 बाट 1 छ भनेपछि 3. So here the lowest cost as per the SPF algorithm, the lowest cost is 3. So the lowest is best. So this path is preferred right now. It will not choose any hope count or something, but it's going to choose only the what cost choose गर्छ ल. Okay, so यो तपाईको चाहिँ shortest path एउटा to reach from a source to destination चाहिँ कसरी चुज गरिन्छ भने SPF एल्गोरिदम को रूपमा भन्छ ल. त्यो चाहिँ SPF एल्गोरिदममा चाहिँ के भयो, हाम्रो कस्ट क्याल्कुलेसन भयो र इट डिफाइन द लोएस्ट कस्ट एज अ बेस्ट. लोएस्ट कस्टलाई चाहिँ तपाईको चाहिँ बेस्ट गर्ने गरिन्छ ल. ओके, सो भयो. अब OSPF युज गर्नुको बेनिफिट्सहरु के छ त, जस्तै व्हाई यु वान्ट टु युज द OSPF ओभर हियर. इफ देयर एनी डाउट देन यु क्यान आस्क है. केही डाउट छ भने सोध्दाखेरि भयो. सो हामीले OSPF युज गर्नुको एउटा रिजन भनेको चाहिँ among the ISP protocols, interrogative protocols, however this support a very large networks लाई अहिले सपोर्ट गरे पनि हैन, एउटा तपाईको लार्ज इन्टर नेटवर्क्स मा पनि वर्क गर्न सक्यो पनि, बट इट्स ISP प्रोटोकल, सो इट क्यान बी युज बिट्विन द डिफरेन्ट एरियाज. भनेको चाहिँ डिफरेन्ट तपाईको चाहिँ एउटा तपाईको डिफरेन्ट भर्टिकल कनेक्सन्स या डिफरेन्ट तपाईको चाहिँ सर्भिस प्रोवाइडर बिच लिंक शेयर हुँदैछ या भने चाहिँ त्यो टाइममा चाहिँ हामीले वर्क गर्न मिल्दैन. इट्स गोना युज इनसाइड तपाईको चाहिँ एउटा ISP इन्टिरियर गेटवे प्रोटोकल्सको रूपमा चाहिँ यसले वर्क गर्न सक्छ ल. ओके, सो अरु हेर्दाखेरि जस्तै EIGRP वाज अल्सो अ टाइप अफ तपाईको डिस्टेन्स भेक्टर नै थियो र रिप पनि तपाईको चाहिँ के थियो, डिस्टेन्स भेक्टर थियो कि. सो दे आर जस्ट गोइङ टु चुज अन द बेसिस अफ होप काउन्टको आधारमा चाहिँ तपाईको के हुन्थ्यो, बेस्ट पास सिलेक्सन हुन्थ्यो भने अहिले तपाईको यसमा चाहिँ के हुन्छ भने यसमा तपाईको चाहिँ इट्स कम्प्लिटली बेस्ड. हामीले हेर्दाखेरि चाहिँ इन्डाइरेक्टली बेस्ड अन द ब्यान्डविड्थ के, लिंक ब्यान्डविड्थमा तपाईको बेस्ट गरेको देख्छ हामीले. सो द्याट इज कस्ट इज अल्सो वान अफ द भर्टिकल एडभान्टेज अफ OSPF. र अर्को भनेको चाहिँ OSPF ले तपाईको चाहिँ एकदमै धेरै लार्जर नेटवर्क इभन देन दैट अफ EIGRP एउटा लार्जर नेटवर्क्सहरुलाई चाहिँ तपाईको चाहिँ के गर्न सक्छ, वर्क गर्न सक्छ. ओके, सो इट्स गोना युज द cost or SPF algorithm that uses the directly bandwidth. Okay, so that is another तपाईको चाहिँ एडभान्टेज हो. र यसमा तपाईको चाहिँ हामीले who use the separate areas so that it will help us to minimize our traffic हैन. अनि तपाईको चाहिँ अब लिंक स्टेट डाटाबेसहरुलाई पनि हामीले तपाईको चाहिँ मिनिमाइज गर्न सक्छ डिफरेन्ट एरियाहरु क्रिएट गरेर हैन. त्यो कारणले हामीले ट्रबल सुट गर्नको लागि पनि के हुन्छ तपाईको मिनिमाइज द व्हाट यु कॉल्ड मिनिमाइज द LSTP टेबल भनौं न एक किसिमले हैन. लिंक स्टेट डाटाबेसलाई तपाईको चाहिँ मिनिमाइज गर्न सक्यो बाइ सेपरेटिङ इट टु द डिफरेन्ट एरियाज, मल्टिपल एरियाज मा के भन्छ वर्क गर्ने भएको कारणले एउटा हैन. र इभन एज लाइक अदर इट अल्सो गो फर द इफ यु वान्ट टु गो फर द व्हाट यु कॉल लोड ब्यालेन्स एन्ड अल, देन इट क्यान प्रोसिड फर द लोड ब्यालेन्स ल. यदि लोड ब्यालेन्सहरु गर्नु छ भने चाहिँ तपाईले लोड ब्यालेन्सहरु पनि गर्न सक्नुहुन्छ यसमा. So up to now any doubt, के सोध्नु छ यसमा?
छैन म्याम।
Okay, so that's why we use the OSPF. ल OSPF एउटा लार्जर नेटवर्क्सहरूको लागि पनि तपाईँको वर्क गर्ने भयो, मल्टिपल एरिया क्रिएट गर्ने भएको कारणले तपाईँको लिङ्क स्टेट डाटाबेस टेबलहरूलाई हामीले डिक्रिज गर्न सक्छ। जुन भनेको चाहिँ यसरी बुझ्दा पनि भयो, इफ यु डोन्ट अन्डरस्ट्यान्ड रिगार्डिङ लिङ्क स्टेट राइट नाउ, देन यु क्यान अन्डरस्ट्यान्ड लाइक वी क्यान मिनिमाइज द राउटिङ ट्राफिक्सहरूलाई होइन, एउटा जुन तपाईँको चाहिँ एउटा ओएसपिएफबाट जेनेरेट भएको राउटिङ ट्राफिक्सहरू हुन्छ त्यसलाई पनि हामीले चाहिँ मिनिमाइज गर्न चाहिँ सक्छौँ ल। सो त्यो एउटा प्रोसेस हो र यसको तपाईँको चाहिँ के हुन्छ नि, अब हेलो टाइमिङहरूको र होल्ड एन्ड टाइमिङहरूको हामीले कुरा गर्ने भने पनि ओएसपिएफ अल्सो गो विथ द पार्शियल अपडेट बिकज फर द फर्स्ट टाइम इट्स गन अपडेट अल एन्ड आफ्टर द्याट चाहिँ इट्स गन अपडेट अन अ पार्शियल अपडेटमा अपडेट गर्छ। सो त्यो कारणले अलिकति क्वाइट प्रोसेस कम छ होइन। अनि अदर भनेको चाहिँ तपाईँको जस्तै यसको हेलो टाइमिङहरूको कुरा गर्ने भने इट हेज अ हेलो टाइमिङ अफ जस्ट 10 to 40 सेकेन्ड, that is the hello is 10 second and then hold is of 4 times, that is 40 second. So it will also gives you a quick update, एउटा छिटो अपडेटहरू पनि हामीले तपाईँको चाहिँ पाउने भयो ल। So here today we are just going to have a look on अब OSPF को तपाईँको चाहिँ आज हामी हेर्छौँ एउटा नेभर कसरी बन्छ भन्ने प्रोसेसलाई हामी हेर्छौँ ल। यसमा कसरी चाहिँ हामीले तपाईँको चाहिँ नेभरहरू क्रिएट गर्न सक्छौँ त्यो प्रोसेसलाई हामी नर्मली तपाईँको चाहिँ यहाँनिर डिफाइन गर्ने गर्छौँ। सो फर्स्ट अफ अल लेट मी गो टु द कन्फिगरेसन sorry configuration part, and here is no auto summary feature. It completely support you the VLSM र कम्प्लिट तपाईँको चाहिँ VLSM लाई सपोर्ट गर्छ। Okay, so to advertise the specific you have to advertise the specific network, then you can proceed with the wildcard max. So let me add some of the network for testing purpose. Okay, that's all. So today we are just going to create the complete what do you call complete scenario on the single area ल। So आज हामी तपाईको क्रिएट गर्दैछौँ complete network लाई एउटै एरियामा in the single area. So here we go. I'm going to use the area 0 over here. So we'll just go for the basic configuration over here. Let me change the host name. Okay. Okay, so the last configuration that I'm going to do. So yeah, no, no. So we all know how to configure the Ospf because I'm already CCNA level of परिसकेको छु. But still, let me go step by step. So here we are planning to use the single area over here. So here, what I'm going to do is that configure terminal. Okay, so I'll just do one thing. You can advertise the Ospf by two of the ways normally. One, you can mention the what you call network and wildcat marks, and second you can directly go to the interface and enable the Ospf. Okay, so what if you just want to advertise or if you are planning to advertise uh, as per the interface, so then you can go directly to the interface and advertise it. Or if you want to advertise, if there is some like a contiguous type of networks over there and you want to advertise at once, then you can go with the network basis. भनेको चाहिँ जस्तै फर इक्जाम्पल R1मा सिमिलर 12 के अरू पनि नेटवर्कहरू कनेक्टेड छ र यु वान्ट टु एडभर्टाइज एट वान्स, देन तपाईँले एकैचोटि एडभर्टाइज गर्दा पनि हुन्छ ल. So however you want, you can advertise. So first we are just going to advertise on the basis of network and then wildcat marks. So here you can say router OSPF and you can mention any of the process ID. Right now I'm planning to mention OSPF 1. And same as the AIGRP, it also has the router ID. And here, if you don't provide the router ID, then it will gonna pick up the highest IP of loopback, or else it will, if there is no any loopback, then it is going to pick up the highest IP of the link. Okay, or if you provide the router ID manually, then it is going to pick up that router ID. But remember one thing, between the peer, okay, between the peer of a same a particular link, they should not have the same router ID. They should have a different router ID. Okay, so if you want to mention manually, then you can say router ID, and you can mention the router ID like this. Otherwise, we have already assigned IP address, so it's going to pick up through that. If you forgot to assign the router ID, then also. Or तपाईले router ID आफैले manually नदिँदाखेरि पनि भयो ल, duplicate चाहिँ हुनु भएन, यो भयो. So now I'm going to advertise the network 12.1.12.0 and it's of 24-bit as per my implementation. A wildcat marks just define the number of hosts over there. So if you have very specific host to be advertised through this network, even though it's of 24-bit, then you can mention it. Okay, so after this you have to say area and you have to provide the area ID. So to implement the area ID, there is a two format. Like one, you can implement as like what you call IP address format. Like for example, if you want to provide the area 10, then you can say 0.0.0.10. Like this you can implement. If you want to provide the area, like for example 257, then you can say 1.0. That is 256 from 0 to 1.1. Okay, so this is how you can implement it. 0 देखि 255 भइहाल्यो, तपाईले कति गर्न सक्नुहुन्छ, 1.1 भन्न सक्नुहुन्छ, 257 भयो नि त. ओके, किनभने यहाँ तपाईको अलरेडी 255 भइहाल्यो अनि 1.1 गर्दा 257 भयो. सो त्यसै डिप्लोय गर्दा पनि भयो. Or else हाम्रो इजी भनेको चाहिँ we can directly implement on the basis of decimal value. And here you have an option up to this much, that is a 4 byte of area ID will be there. Okay, so I'm going to implement the area 0 as per my network. So similarly, I can advertise my link, that is 111.1.11.0, sorry, 11.0, and it's of 24-bit, and it will also belong to the area 0. Fine. So here, there is no any OSPF neighbor formed yet. I can say OSPF neighbor, there is no any OSPF neighbor. If I go to the database, OSPF database over there, then there is just a single like router over here, and a router link state ma if the router associated, that is 1.0.0.1. There is no any more routers over here, and link count is 2. That means you just advertise the 2 links of router 1. So it also mentions that and say how many links you want to advertise or you advertise, and that will be counted over here. Okay. Also you can say so IP OSPF interface brief, and you can see whatever which interface you advertise and what is the subnet or networks or the prefix of that of that interface, and what is the process ID and what is the area ID and what type of network it is. We'll talk about this later, and how many neighbor is there. Clear? So कतिवटा नेबरहरू छ त्यो यहाँनेरि सबै मेन्सन हुन्छ. So जति तपाईले एडभर्टाइज गर्दै जानुहुन्छ, it will be added on this one. So let me go to the router 2 and let me advertise the network. So I'll just say router is web process ID. I can mention 2, it doesn't matter. Okay, so I'll advertise 12.1.12.0. That is a 255 and area will be 0. Okay, and similarly I can advertise to the 23.1.23.0 and that's of area 0. Clear? So here you go. So once I advertise the same link between the two of the router on the same area, then they are going to form the neighbor, and one of the neighbor is formed. Your neighbor indicate the neighbor ID. Okay, a neighbor ID means that is a router ID, and it will go to the loading to full. We'll talk about the neighbor process and all later on. So here you can have a look now. So IP OSPF database, and now in the router, don't check on other one. I'm just router link state material. So now you can see there are the two routers over here, and here it's saying that router 2 also hosts the two links. I can say one thing. I can do one thing. Let me do one thing. Like I wanna connect one more link that is 12.1.1. Not 12, 102.1.1.1. Okay, and let me advertise to the router OSPF 1, not 1, 2, and the network is this one, and the area will be of area 0. Okay, so now let me check the check over here. So IP OSPF. Now here you can see the link count is 3. So complete information is carried out. The identical information should be there in each of the router. So this is the information. This is the LSTP table that is created by the router 1 for the router links of the area 0. Okay, so if you go to the R2, then you will see the same thing. So IP OSPF database. So here you go, you can see the same information. Clear? तपाईले त्यहाँ पनि के गर्नुहुन्छ, सेम इन्फर्मेसन देख्नुहुन्छ ल. So that is the reason. So once I edit more, just like for example मैले तपाईको चाहिँ R3 मा पनि एड गरे भने, जस्तै म R3 मा पनि तपाईको चाहिँ के लिंक एड गरे ल, फेरि मैले R3 लाई पनि तपाईको चाहिँ एडभर्टाइज गरे. So router OSPF 1, I can say anything. So the network will be 23.1.23.0, 0.0.0.255, and the area will be 0. Fine. So here you can go to the R1. We need to wait at least 40 seconds. Okay. So once it will form the peer and all. Wait for a certain time. Okay. Neighbor से के भन्नुस् तपाईको opposite. Okay, neighbor बनिसक्यो. So फेरि यहाँ गरे नि. So you can see the database table has been increased. Database table के भइरहेछ तपाईको increase भइरहेछ ल. So यसरी तपाईको जति राउटरहरु increase हुँदै जान्छन् के हुन्छ तपाईको यो database table पनि तपाईको increase हुँदै जान्छ के. So there you can see, and this database table are identical to each of them के. यसमा पनि same thing. And if you go to the R3, then it's same. Do so IP OSPF database. Clear? Same हुन्छ ल. So same हुन्छ के. यसरी तपाईको चाहिँ हाम्रो के हुन्छ, database टेबलहरु चाहिँ increase हुँदै जान्छ ल. If you edit 4, then again the database table will increase. So what will happen whenever we go through the larger deployment, then it will be too much larger भएर जान्छ के. So it will be difficult to handle. Clear? So if I did something like this, for example, I created the area 0, and up to here Up to here, I want to set it with the area 0. And from here, I want to set it with the different area. Clear? First, I want to deploy, I want to like advertise all the networks on the same one. पहिला चाहिँ मैले सबै नै के गरे तपाईको चाहिँ एडभर्टाइज गरे। सो मैले के गरे भने यसमा मैले अर्को साइटको नेटवर्क पनि मैले एडभर्टाइज गर्दै, जस्तै 34.1 र 34.0 पनि मैले अहिले सेम एरियामा एडभर्टाइज गरेँ। क्लियर? R4 लाई पनि मैले के गरे तपाईको चाहिँ, so router OSPF 1 and the network can be 34.1 to 34.0, 0.0.0 to 255, and it will be an area 0. First thing, okay. So let us wait for a certain time to form the peer. At least you need to wait for 40 seconds, minimum. Serial link मा क्विक हुन्छ र तपाईको चाहिँ हाम्रो इथरनेट लिंकमा अलिकति टाइम लाग्छ। त्यो पनि हामी भन्छौँ वाइ किन भन्ने कुराहरु त्यो हामी डिस्कस गरिहाल्छौँ। Okay, so now let me go to the R1 and you can have a look. Now the database table has been increased. यो यति भइरहेछ नि त अहिले database table. So what I'm going to do is that now I just want to divide it to the, I want to assign it to the different area. Maybe for example, I can assign to the any area, it doesn't matter. I want to assign to the area 34 to them. Okay. So here I'll just remove it because I don't want to advertise it. यसलाई मैले remove गर्दै र R4 को पनि यसलाई मैले remove गरेँ, not on the area 0. But now I'm going to implement it on area 34. Fine. And the link, particular link must be on the same area, area 34. यो मैले गरेँ भने in this case what will happen? Let us just wait till the neighbor form. अब यसमा हेर्दाखेरि अघि तपाईको चाहिँ चारवटा राउटरको हामीले इन्फर्मेसन देख्थ्यो लिंक स्टेट डाटाबेसमा। Now we'll just see the 3 of them. तीनटे मात्रै देख्छ। हाम्रो नेबरशिप बनुन्जेलसम्म चाहिँ हामीले वेट गर्नुपर्ने हुन्छ पहिला, हैन? So let's just wait for a certain time. Okay, so let me go to the R1 and have a look whether the update of R4 has been edited or not. Okay, अब यो 34.1 to 34.4 means not a link. Okay, यो चाहिँ तपाईको राउटर आइडी हो है, यो चाहिँ के हो तपाईको यो राउटर आइडी हो ल। So यो चाहिँ तपाईको राउटर आइडी एन्ड सो गरिरहेछ। So here you can see the 3 of the information on the area 0. Clear? Area 0 मा के छ, पहिला 4 टा इन्फर्मेसन थियो, अब के भयो 3 of the information is there. So now if you go to the R3, then you will see 2 of the different database. OSPF database. Ospf has a database of both of the area. First in area 0, it will take time. Let us just go downward. Okay, so here you can see on the area 0, okay, on the area 0 it has the information of this one. यतिको इन्फर्मेसन हामीले देख्न सक्छौं। अब नेटवर्क लिंक स्टेट को पनि हामी पछि कुरा गर्छौं। So it has a area 34 and area 34 has information of 34.1 to 34.3 and 134.1 to 10.1. Why? Because on the area 34 they belongs 2 of the router belong over here के R3 र R4 के गर्छ area 34 मा belong गर्छ ल। यो देख्यो भनेपछि if you go to the R4 then now SWIP OSPF database, so it will just have information of area 34 only. Area 34 को मात्रै उसमा के हुन्छ तपाईको लिंक स्टेट डाटाबेस चाहिँ कन्टेन हुन्छ ल। 34.1.34.3 and 114.1.10.1. So this is a benefit of creating the multiple area, but don't try to create the multiple area if that is a small network. Okay, so if that is a larger network, then you can proceed through creating multiple areas. Fine. So this is how the OSPF works. And also if you want to see the complete thing over here, like SOIP OSPF interface brief, that means it will show you the complete what you call informations of the interface that you have advertised on the OSPF. So it also mention you the cost also. Cost पनि के हुन्छ mention गरेको हुन्छ ल. So this is the cost of this link 34.1 to 34.4 between this link. यो अहिले gigabit ethernet हो, so the cost will be 1. Fine. So the cost अहिले यति छ भनेर send भइरहेछ ल. So whatever the number of link that you advertise, it will be noted over here. Like this you can see. So भनेपछि यसरी हामीले चाहिँ multiple area create गर्दा अहिले R1 मा के छ तपाईको यति इन्फर्मेसन्सहरु छ area 0 को. So R4 मा only this much. Clear? So this is how you can implement the multiple area in the OSPF. But remember one thing, there should be area 0 to share the link of area to share the link between the different area. Different area is communication garaunu छ भने चाहिँ त्यो हुनै पर्छ. So IP route, and here the OSPF link is noted as O, and if there is an inter area routes that like for example area 34 belongs to the different area, then that of area 0, then it will be noted that OIA. OIA भनेको चाहिँ के हो तपाईको चाहिँ OSPF inter area, same area हो भने चाहिँ O मात्रै हुन्छ. Okay, inter area हो भने चाहिँ IA हुन्छ. 110 is the AD value, administrative distance of OSPF, and this one 2, 3 is this one is the cost. Okay, so to reach from R1 to up to 144, if you go downward, where's the 144? I think I haven't advertised it. So to reach to 34 network from R1, the cost will be कति हुन्छ जस्तै यो लिंकको cost 1 भयो, यसको 1 हुन्छ, so यसको 1 भनेपछि R1 बाट त्यहाँ रिच गर्नको लागि 3 हुने रहेछ ल, because we know that this is a gigabit ethernet, so it will have the cost of 1. Cost कति हुन्छ 1 हुने गर्छ ल. So up to here 3 भयो, so 23 को नेटवर्कमा रिच गर्नलाई चाहिँ 1 + 1 2. It's not a router count. Your router count होइन ल. Let me do one thing. I just say interface gig 0/0 IP OSPF cost. I'll say 10. Fine. So on the router 2 also let me do the same thing. So interface gig 0/0 IP OSPF cost is 10. Normally we don't increase or decrease like this, but I just want to show you. That is a reason. So here you can see right now the cost of gigabit link R1 and R2 is of 10. Okay, so if I check the route again, so IP route OSPF, so there you can see that 34 has a cost of 12. Why? Because it has cost of kati. Isko cost sa tapaiko 10, 1, 1. So 10 + 1 + 1 12. Okay, so this is not a router count. This is a cost calculated by the SPF algorithm. Fine. So right now we just have a single link, so it's gonna choose the same path. And here you can see the time update and the exit interface. Okay, so this is how the OSPF advertise the routes. So up to now, any doubt, anything to ask?